students, we are going to see some details about multiple integrals. Before I go to multiple integrals, let us see first a single integral. Okay, integral a to b f of x dx. Now this particular f of x, this is called integrand, and these limits are for x because x is the variable of integration. This particular x, variable of integration of, and this x is starting from a and this x is ending at b, so this x varies from a to b. These are called limits of integration, limits of region of integration. Now the question comes, if we calculate this integral, what we get? Then integral a to b f of x dx from x is equal to a to b, by taking this f of x as 1, for example, very simpler situation, I am taking here f of x as 1. Okay, now integral x is equal to 0 to 4 just dx means the integrand is 1 in this case. So here this is going to give as x, integral dx is x, limits are from 0 to 4, so this will come as 4 minus 0, that's equal to 4. This 4 is nothing but the length of the interval. We are starting from 0 and we are ending up to 4. 1, suppose 2, 3, 4. Now this particular shaded one, I mean to say, here I'll change the color now. Okay, this particular interval is from 0 to 4 and length of the interval is equal to 4. Keep in mind the integrand is just 1, then whatever limits are there for the integral, the domain of integration or the region of integration will be there as per the limits, and the length of that particular interval or length of that region is given by that integral. Now let us go for this case of double integral. Suppose I have integral x is equal to 0 to 1, integral y equal to 0 to 2 dy dx. Because it is a revision class, I'm assuming that you know certain things, I'm skipping certain things, but my aim is to make you clear about all minor basic things, so I'll try my level best. Now this is nothing but equal to integral x is equal to 0 to 1. First you are integrating with respect to y because the inner integral is with y, so integral dy is y, limits are from 0 to 2, and then dx you are keeping as it is. So integral x is equal to 0 to 1, 2 minus 0 into dx, that's nothing but 2, that 2 coming out, integral dx from 0 to 1, that is nothing but equal to 2 into x from 0 to 1, that's equal to 2 into 1, that's finally 2. But one suggestion to you is that for this particular integral, suppose let us say let I is equal to this one, then I can write that I equal to, because the limits are in constants, be careful, I'm saying one very important point here, the limits are all the constants. Okay, I mean to say all the limits are constants, no limit is a variable. In this case you can write this double integral as a product of two single integrals. Now that same I'll write that integral x is equal to 0 to 1, y is equal to 0 to 2 dy dx, that can be written as a product of two single integrals, one only in x and one only in y. Y is equal to 0 to 2 dy. This chance of writing the double integral, writing the double integral as product of single integrals. This chance is available only for constant limits, constant limits we have this chance. So this can be written as just x from 0 to 1 and y from 0 to 2. So it is just 1 minus 0 into 2 minus 0, and this is just finally 2. And we can take the advantage of this particular concept even in the triple integral. Suppose let I is equal to integral x is equal to 0 to 2. Not necessary that it should start with 0. I can take with 1 to 3, and z is equal to some 2 to 4 dz dy dx. Actually this is a triple integral and it constant limits. It can be very easily written it as, therefore I is equal to, let I is equal to this much, therefore I is equal to integral. Now what I am doing is I am separating the three integrals. Okay, I am writing it as a product of three integrals, 0 to 2 dx and integral y is equal to 0 to 3 dy and integral z is equal to, I'm sorry, it is y is equal to 1, y is equal to 1 to 3 and z is equal to 2 to 4 dz. And this particular splitting gives very easy evaluation, means we can find the value very easily. Evaluation is the process of finding the value. So it is 2 minus 0 into 3 minus 1 into 4 minus 2. That result comes very simple, 2 into 2 into 2, that's equal to 8. Now we can use this concept also if there are more number of terms inside that integral. Suppose integral is x is equal to 1 to 2, y is equal to 3 to 4, z is equal to 5 to 8. xy plus x square z. If this is the situation, dz dy dx, even though it is given in this order, we can break the order, we can skip the order and directly write it as this. Let it be I. Solution I can write it as, first I am separating it, that triple integral I am separating for xy and that triple integral I am separating for x square z. And okay, this for saving time I am not writing the limits. Okay, and now I can write this as a product of three integrals. So integral x, that will become x square by 2 from limits from 1 to 2, and integral y is y square by 2, limits are from 3 to 4, and there is no z, so integral dz will become z and the limits will be from 5 to 8. Plus for this x square z, x cube by 3, limits are from 1 to 2. I am taking direct steps here, assuming that you will be there following. Integral dy, there is nothing, there is no y term here, so integral dy will become y and limits will be from 3 to 4, and integral z is z square by 2 from 5 to 8. I am not simplifying because you can get it very easily, you will get these values. So this value you will get it. So keep in mind, I am stressing more that this, okay, I'll write it here, constant limits here in the, okay, lower limit and upper limit both are, or they are all constants, all the 6 limits are constants. Then break in the sense that you can write it as a product of 3 single integrals. Here there is one term, that is why that is coming. Okay, there are 2 terms, so because of these 2 terms you have breaked into 2 parts. If there are more number of terms, you can break it into more number of parts. So this is the easy way of calculating the triple integral or double integral in the case when the limits are constants. So when the limits are variables, order should be followed, and sometimes change of order is required, sometimes change of variable is required. So let me conclude the point now that I'm concluding the point in this short video. What we have seen here is that this f of x is called as the integrand. This a to b are the limits. X is the variable of integration. So this interval from a to b, this is called as the region of integration. So if nothing is there inside, I mean if there is just there is just 1 here, there is nothing inside, means integrand is 1. At that time the length of the integral, length of the domain or region will come. If nothing is there here, it will come as the area. Now you just verify this concept, how it gives the area. X is 0 to 1, so let me take it that this is for example 1 I am taking, so it is 1 and it is 2 here. Y is varying from 0 to 2, so I get a rectangle. This complete rectangle area will come, that is base into length into breadth. So this is 1 and this is 2, so 1 into 2 is equal to 2, and you got that 2 here. That is nothing but you got the area of the region of integration. This is the region of integration. Now here you can get this here I just said that no need to follow the order. Here we have followed the order, followed order, but then I have shown you that order need not be followed for constant limits. When the limits, all the limits are constants, lower limits and upper limits all are constants, whether it is a double integral or triple integral. Only for constant limits, this double integral you can write it as a product of single integrals, and you have written it and you have verified that it is coming to. Now in the case of triple integral, you will get the volume, of the region. For example, if somebody calculates, let I is equal to integral x is equal to 0 to 1, integral y is equal to 0 to 2, integral z is equal to 0 to 3, dz dy dx, then let me say that it is 1, and then this becomes 2. This is x-axis I am taking, this is y-axis, and I am taking this as z-axis. Then here it will be 1, it will be 2, it will be 3 roughly. So I get a rectangular parallelepiped. This rectangular parallelepiped, the volume of this complete rectangular parallelepiped will be equal to integral dz. Now integral dx is x, integral dy is y, and integral dz. Because I am separating that integral, I am changing the color of the pen so that you will be able to see. So this integral with this dx, this with the dy, and this with the dz, integral dx is x, integral dy is y, and the limits are from 0 to 1, and here the limits are 0 to 2, and the limits for z is 0 to 3. So that is equal to 1 minus 0 into 2 minus 0 into 3 minus 0, that is equal to 1 into 2 into 3, that is like length into breadth into height. So that 6 is nothing but the volume. So keep in mind, if there is a multiple integral and nothing is there here, just 1 is there, and dz dy dx, that gives volume. And if there is a double integral, there is just 1, and dy dx, that gives area. Whatever limits are there for the region, there is some region here, there is some region is here, and there is some region here, there is 1 only, and dx, this complete gives length. So now comes the important point, that how should we evaluate a evaluation of a multiple integral. Now I'll tell you some cases. Suppose if it is given, evaluate integral over r some x square plus y cube into dx dy, where r is the region, given by given by x equal to 0, y equal to 0 and x plus y equal to 1. So that region is nothing but this is the straight line with x intercept 1 and y intercept 1. So suppose if I take this as 1 and this as 1, so this is the straight line and this is the region of integration. How to decide the limits of the region? I am separately recording another video for deciding the limits of the region. So limits of region will be discussed in separate video. I will upload it afterwards. Suppose the question is evaluate double integral. Okay, some limits are given actually. Some function is given here, dy and dx by change of order. Then on this change of order, I am going to separately record another video. Okay, another video. I'll just another video will be separately for change of order of integration. Change of order of integration. And there is another situation where you have an integral in x, some limits are given for x, some limits are given for y. There is some function and there is dy and dx. It is difficult to evaluate this one. Then sometimes we will take into conversion of polar, we will convert this integral into polar coordinates. This is actually into, this is in Cartesian coordinates. What are Cartesian coordinates? What are polar coordinates? I have already uploaded the video, basics for understanding the problems of multiple integrals. Before this video I have already uploaded that one. You can see that video. So if you convert it, the conversions are, the bridge equations are x equal to r cos theta, y is equal to r sin theta. Then this integral I, instead of that x and y, you will be getting the limits for r and you will be getting the limits for theta, and there will be a function in r and theta, and there will be r into dr into d theta. This r is the Jacobian that comes extra when dy dx is replaced with dr d theta. This r is the Jacobian. If the conversion is done to some other coordinates, there will be another value of Jacobian. Instead of r, there will be something. So this is discussed as change of variables. So you may change from Cartesian to polar, you may change from Cartesian to some other coordinates. So change of variables of integration is another concept. Change of variables of integration. So there are three things in final conclusion. That is nothing but finding the limits and finding the what is meant by the order of integration and what is meant by change of variables. So I will discuss one by one how to find the limits, how to change the order of integration, and how to go for change of variables. These all three things I will separately record in separate videos. I hope you understood this part. And if there is a just constant limits problem is given, directly split it, and if it is having more number of terms, you split into two parts and then you again separate into single integrals and do it. This is the easy way. So I hope you understood. And for understanding all these three concepts, okay, so how to decide the limits of the region and how to change the order of integration and how to change the variables of integration, change of variables of integration, you watch separate videos. I will make it and upload it afterwards. Okay, thank you.